Assalamu alaikum everyone, my name is Ahmed and welcome to my channel. And we are finally going to containerize and deploy our Rust web app. This video is split in two parts. In this video, we are only going to containerize and run locally. And in the next video, we will deploy to a VPS. We got a lot to do, so let's get started. Now to follow along, you must have Docker Desktop installed on your computer. If you don't have, then go to their official website, then download and install on your system. And I hope you know why we containerize at a basic level. And I'm inside a very basic Rust server which has only one route per health check and it returns 200 OK. Now if I go ahead and run the server, then curl health endpoint, you can see it returns a 200 OK status code with this string response as you would expect. Now at the root of this project, create a Docker file with capital D and without any file extension. You can name it anything you want, but using the default name allows us to run the docker build command without having to specify any additional command line flags. Inside this file, we're going to write instructions to build our image. An image is a self-contained file that contains all these packages, binaries, OS libraries, configuration files, and everything to run the image. We are going to build the image in multi-stages and in layers. So using multiple stages will let us create a small final image. And layers will add cache. So in the future when we will rebuild, we can use cache of that layer if nothing has changed in that layer. Type prom, which is an instruction. It is case insensitive, but it's a convention to write in caps to avoid any confusion with arguments. Here is the list of instruction commands like instruction followed by arguments. This prom command will create a new stage. We will start with the base image of Rust. To build Rust app, we need a Rust Docker image. Go to this website which is hub.docker.com and search for Rust. As you can see, it's labeled as official image. And here you can see different variants. And you can see the version which is 1.87, which is the latest version as of recording the video. And you should update your version to latest and use that. And if you scroll, they talked about all variants. Definitely give it a read. Alpine being the smallest and has fewer dependencies, which is aggressively small. And Slim is slimmed down version has more dependencies than Alpine, which is somewhere in between, unlike the default image, which contains everything and is the largest in size. In this video, we are going to use the Slim variant. Anyway, back to the Docker file. Now add a colon to add the tag. The tag is version 1.87, which is the Rust version, as you already know that. Slim variant and bullseye, which is the Debian version 11. We're going to run our Rust binary on Debian Linux. Then type as to give this stage a name. So later on we can refer to it, call it shape or any name you want. Now before we continue, I want to mention that I'm going to use cargo ship. I've been using this for a while. I think it's better to use something that already exists rather than reinventing the wheel. Anyway, let's continue writing this Docker file. Now we have a Rust toolchain, so we can run cargo install command to install cargo ship. Then set working directory, choose app. And now this is our first stage, so I'm going to add some comments around that. Next is the stage 2. This time we're going to start with the image from the stage 1, which is called shape, and name this stage to planner. Now the question is, why would we create separate stage for that? Because we need a base image with Rust toolchain with cargo shape installed, and we need this twice. Then copy command followed by 2 dots. The first dot is for source location, which is everything inside our project files like the src, target folder, and so on. And the second dot is the location of destination, which is current working directory inside the image. Since we set it to app, so it will be app directory of this stage. So now everything will be copied inside the image, but we don't want everything to be copied like this target folder, which is unnecessary to build our project. So we can create a .docker ignore file just like git ignore file and add target folder. And now the target folder will be ignored while copying. Next, run cargo ship command. Then the pps hub command, which examines the project and builds a recipe file. and that captures the setup information required to build the dependencies. Then the recipe path flag is to set the path of recipe.json file. We need this JSON file to build our dependencies, which we will do next. Next, stage 3. And again, we start with the same image, shape, and call it builder as usual, which contains Rust and cargo shape and so on. The first thing we're gonna do is we're gonna copy the recipe.json file from planner stage, which is inside the app directory, to this stage's app directory. Because the previous stage will be discarded, we will take only the important things. Then run cargo shape cook in release mode to build our dependencies using the recipe.json file. And this layer will cache the dependencies. Then copy everything from our project. Now we did that in previous stage, but that stage is now discarded. So we will do that again here. And finally we will build our project in a release mode, which will be a Rust binary. But we need an OS to run it, right? So in our last stage, which is going to make the final image, start with Debian Bullseye Slim. If you remember, our Rust image is also Debian based Bullseye. Then copy the binary from previous stage, and Rust binary is located at app target release, and the name will be dummy because we named it in our cargo.toml file. And copy the binary to user local bin of this stage. Then expose port 1990, which we are listening on in our app, and finally set the entry point to our binary path. This command tells when the container starts, run the program as an executable. Alright, so let me give you a quick rundown of everything. You can skip this if you want. Generally, when you update your code, you would rebuild your Docker image, basically throwing away old container and recreating a new one. And to minimize the build time, we went through all of this. Now, if you change the Rust version, then next time when you rebuild, it will start from stage 1, which is starting fresh. But if you don't, which you would do rarely, Docker will use the already downloaded cache version and skip this. Then if you change dependencies or update any dependency version, and even if it is a single dependency, then it will start from here and create a new recipe.json file. But if you don't change any dependency or its version, which you would do once or less frequently, then it will skip and go to next stage, and this command cargo shape cook cache the dependencies which will be used. Then it will copy the source code and build, which is obviously since you changed something in your code. Therefore, you don't have to pay for extra build time or download or caching. And of course, this image will be used from cache. Now, remember that we are talking about build time in CI pipeline, like GitHub CI/CD, not on your machine, which is very fast. So we need to squeeze every bit of time. Now, let's build our image. But before we do that, make sure Docker is running in the background. Anyway, type docker build, and this command itself builds the image, but it won't give any name. So it will be difficult to identify, especially in CI/CD build script. So add the flag G to give a name. You can give any name you want, but you should add your Docker registry username / the image name, then colon, then the tag. It could be a version or something like latest or anything you want. Then space and the dot. This dot tells that find the Docker file at the root of this project. Now let's go ahead and run this command. And you can see it's building. And it's downloading the required images and everything we talked about, all these stages and so on. Once that builds, then if we go to a separate terminal, not that we can't do inside the indicator terminal, but that might confuse you. And here if we run docker images command, that will list all images, and you can see the image we just built. Now let's go ahead and spin up a container using this image. So type docker run, then -p to map the port. The first port 1990 is the port of the host machine, which is my computer. Then the port of the container's internal port, it has to be 1990 because our server is listening on this port. So now when we try to access the server that is running inside the container, will be available on port 1990 of the host computer. And this host port could be different. It doesn't have to be the same as container's internal port. Then deflag to run in detached mode, which will run in the background. Then the name of the image, finally run it. And if I run docker ps to list all containers, you can see the running container, and this is the container ID. Now let's call to health endpoint, and we get an empty response from the server. The reason we get an empty response because we are listening on 127.0.0.1 IP address. Instead, we need to listen on all IP addresses, which is 0.0.0.0, which is 4 zeros. So the container can accept connections. Now we changed our code, so we have to rebuild our image. Same Docker build command, and you can see it built way faster. It built everything from cache and took about 7.3 seconds, but before it took about 174 seconds. Anyway, first we have to stop the container, so we can list all containers, then get the ID and stop it. Using the command docker stop, then the container ID. Then run our image again using docker run command, same as before. And if we curl to health endpoint, we get 200 OK response with this string. Now we built our image, and we can also distribute our image so other people can use it, just like Rust or Debian image you saw. But before we do anything, we have to log in. So run docker login, but you must create an account first. So go ahead and do that, and make sure to choose email and password. Anyway, login should be straightforward, as you can see. Once we logged in successfully, we can now push our image to Docker registry. Then run docker push, then the name of the image with the tag. Once that's done, we can visit hub.docker.com/repository/the username. And you can see the image name dummy. I just pushed it here. And now you can pull this image and build and try for yourself. And that will work on your machine exactly like mine. So far we worked on a basic dummy server. So let's go ahead and work on a complex web server with database. We built this in axum tutorial series. If you are interested, you can watch that, but it's not required. Anyway, go to the link in the video description and make sure you are on the branch 8, and then download the source code and open it in your IDE. And here I already added a few empty files and folders like .github and scripts folder and docker ignore compose.yaml and docker file. Nothing too crazy. I will explain them as we go along. You already know about docker ignore and docker file. And I copied everything from dummy project's docker file to this project. And finally, I added a test for the sake of testing. As you can see, health check endpoint returns 200 OK status. It's a basic test, but generally you will write test well, especially when it comes to CI/CD. Now let me run cargo test and show you it's working. And you can see it's all passed. Now if you remember, in this tutorial we are using SQLX query macro, which checks queries against the live database connection during compile time. But we can't have a live database connection in an offline environment, so let's go ahead and enable offline mode. Inside this Docker file, before we build our app, set SQLX offline environment variable to true. This tells SQLX macros to use offline metadata instead of live database connection. Go to the terminal and run cargo SQLX prepare, and that will generate all query metadata inside this .sqlx folder. And you must add this directory to Git. This is important. It must go inside your GitHub project. Remove this expose port from here. We will do that from docker compose file. And finally update the binary name which is mentioned in the cargo.toml file. Docker Compose lets us manage and orchestrate multiple containers as part of a single application. Previously you saw we ran a single container. Now when we need to run multiple containers together and they are interconnected and depend on each other, we can write the configuration in Docker Compose. So it's basically a setup configuration. With just one command docker compose up, we can spin up the entire stack at once. Anyway, it's an YAML file, so it's written like key value pair. I hope you know that. First, give the project a name. By default, this will use the folder name. Let's define two services, which will be configuration for two containers. The first service called website, and the container name will be website. Now they don't have to be the same. The service name website will be used to refer each other within the compose file, and the container name, well, it will be the container name when we spun up. Then build dot, which will build the image using this Docker file. Only for now, we are building from compose file, but later on we will link to the image from Docker registry. The second service is DB, and you can see I linked to Postgres image. Docker will pull that image and spin up another container named DB. Also set restart unless stop just in case the container stops by itself or system reboots, then restart it unless we stop it manually. Then set some environment variables, database name, user and password, and we won't hard code them here. Instead, we will pass that as variable. Later on, we will set that from GitHub. Then in the website service, set depends on to DB, which ensures that Docker will start DB service before website. Although it doesn't guarantee if the database is actually working. You can do health check or something, but we are not gonna do that. Next, set database URL in environment variable, which you are already familiar with. Just keep in mind that this add DB must be the service name DB. They have to be equal. Then set time zone because we are going to deploy there. And finally the port mapping, which again you know that we are mapping port of this host machine to Docker container. And I made a mistake. The container port is 8000 not 8080. If you go to main.rs file, and you can see it's 8000. Now we could change it to 8080, but I don't want to do that here. And also the IP should be 40. Now update the container port to 8000 here. Now it's totally okay to keep the host port to 8080, but I would suggest you to also change it to 8000 because when we start our server, it will tell that it's starting on port 8000, even though we will remove this port eventually and we won't listen to 8000 when we will deploy and add a reverse proxy. But anyway, let's keep it to 8000. Then go to .env file and add some environment variables which are required by the Postgres database, as you can see. Now let's go ahead and spin up our stack. Run docker compose up -- build. This -- build flag will build an image from the source because we define the location here. Then spin up a container from that image, and you can add an additional -d flag at the end to run in detached mode. Once that builds successfully, go to the browser and visit localhost 8000, and you can see there is no style because the server failed to serve static files. So when we compiled our binary, that only included the Rust source code. It didn't include the static files, and we are running our binary from Docker, so we could copy static files into Docker, or we could use a CDN for that if you want. But what I would like to do is embed the static files so our binary will contain everything. So add these two dependencies, Rust embed and mime guess. Open routes.rs file and remove this subdirectory. We won't use that. And add a new route on path/static/* file path. This * file path is a wildcard path parameter that matches anything that comes after /static. Then we can use path extractor, which you know that. Now this path will have only get method with get embedded static files handler function. You can name anything you want if you don't like this name. This function doesn't exist, so go to public.rs file and add this handler function with path extractor, obviously. Then import that in routes.rs file. Now I'm going to copy and paste some codes from the doc in helpers.rs file. This asset struct is the source to our static folder because it derived from Rust embed macro, and then we set the location to our static folder. Then another public struct static file which has a tuple of one field. Then implement into response for that so we can convert these to response object. Therefore, we can instantiate this struct and use as an API to access static files, which can also be converted to a response object. Then inside into response function, first get access to tuple pill using index 0. Once we have the path, try to get the static pile on that path from asset. This returns option type, so inside the sum type, first get the mime type using mime guess. Then set the response content type header to mime type of that pile. Then the actual static pile wrap in a tuple and return as response. If it's an invalid path for the static pile or the file doesn't exist, then from the none type return not found status code. After that, from get embedded static pile function instantiate static pile and pass the path. Anyway, now stop the containers. Then most important part is to remove all running containers by running docker compose down command, then docker compose up -- build again. And you can see we are able to access static piles from embedded binary. Alright, so before I wrap up this video, I wanted to show you something. So if you check this log, you can see two containers, DB and website. And there is a network, which is the default network. If we don't define any network, Docker will create one. A network is to communicate with each other and outside. So let's define a network and call it app network. And this is how you define network. Then give both database and website container this network, and they will communicate using this network now. Nothing really has changed, and this might seem redundant, but in the next video, we will create a different network to communicate with outside for better security. Now let's go ahead and build, and this time add the -d flag to run in the background. And you can see now Docker created a network named app network instead of default network, and everything is working fine. And finally, don't forget to run docker compose down to clean up everything created by docker compose, like containers, network, volumes, and so on. So you don't have dangling stuff that will clutter your Docker environment. And that's it for this tutorial. Don't forget to watch the next one, where we are going to deploy our app. If you like this video, then give me a like and subscribe if you haven't already. And I will see you in the next video. Assalamu alaikum.